Hello everyone. So welcome back to the next lecture of our Laplace transform. In the previous class I have given explanation of what is Laplace transform, definition. So we have seen a Laplace transform of a function f of t, which is nothing but integration of 0 to infinity e raised to minus st f of t dt. So this definition we have seen, as well as two of the proof which is nothing but one of the formula for our Laplace transform I have proved. So so you will understand how this Laplace operator is going to be applied using the definition. So in today's class we'll see the formulas of the Laplace transform. So with those formulas we are going to prove the results of Laplace transform. But to prove those Laplace transform formulas, we need help of our trigonometric functions, which is more almost basic criteria what we have seen in the PU level. So with the help of those integration differentiation formulas, we'll apply our Laplace transform and will transfer the function t in terms of s. So let's see what is the list of the formulas and we can work out the table now. So we'll see the first formula. So which one already I have proved in the previous class, that is first formula. So Laplace of A. So Laplace of A is a constant, so A upon S is the result here. So first result, so Laplace of constant or Laplace of A is what here? A upon S. Second formula, which one also we have proved in the previous class, e raised to Laplace of e raised to at is nothing but 1 upon s minus a. If it is plus a, we'll get minus a, and if it is minus a, we'll get plus a. I will consider as one more formula, that is formula number 3. Laplace of e raised to minus at is equal to 1 upon, because of this minus it will become s plus a. So formula number 3. Next formula I will take formula number 4. So concentrate and see here. So it Laplace of cos hyperbolic of at. Okay, so Laplace of cos hyperbolic of at is given by, it is s divided by s square minus a square. So remember, so Laplace of cos hyperbolic of at is s divided by s square minus a square. Next formula is Laplace of cos of at. Just see, I have taken simultaneously both hyperbolic, what happens, and only trigonometric functions, what happen. So Laplace of cos hyperbolic of at is s divided by s square minus a square, and Laplace of cos of at is s divided by s square plus a square. Because of hyperbolic, minus sign will come. Because of trigonometric, plus sign will come. So these are the differences, look like same, but here because of hyperbolic you need to remember it is minus sign, and because of trigonometric, cos at is a trigonometric function, it will become plus sign. So these two formulas you have to remember. Next, sixth one, Laplace of sine hyperbolic of at. So Laplace of sine hyperbolic of at is given by a divided by, this a is nothing but this a, what coefficient of t is there, that a. Okay, so a divided by s square minus a square. And seventh formula, Laplace of, this is sine hyperbolic of at. Now sine of only at, not hyperbolic, only trigonometric function. At that time it will become a divided by s square plus a square. So similar how we have taken in the cos, sine also. Denominators are same, but if cos is there, s denominator numerator will come s. If sine is there, numerator will come out here a. This a is nothing but coefficient of t. If suppose here sine of 2t is there, so at that time it will become 2 divided by s square plus 2 square. If it is 3 is there, 3 divided by s square plus 3 square. If nothing is there, sin t is there, so 1 divided by s square plus 1 square. So you need to remember these formulas. Okay, so next one of the very important formulas is 8th one, that is Laplace of t raised to n. So Laplace of t raised to n, it is given by two formulas. So first formula is n factorial divided by, okay, n factorial divided by s raised to n plus 1. So this, you just see that what is the power of t. If power of t is integer, that is whole number, so n will take 1, 2, 3, 4, so on. At that time we are going to use n factorial divided by s raised to n plus 1. If n is not a integer, whole number, so at that time we are going to use gamma function, that is gamma of n plus 1 divided by s raised to n plus 1. So what is n here? N is nothing but just like a fraction, that is 1 by 2, 2 by 3, 1 by 4, so on. If in such case, if n is in terms of what here, p by q form, okay, if n is what here, n is p by q form, at that time gamma of n plus 1 divided by s raised to n plus 1. So you have to be careful. You have to see that what is the power of n. If n is whole number, I can say that, or integer, that is 1, 2, 3, so on. At that time we are going to use n factorial divided by s raised to n plus 1 formula. If it is fraction, that is p by q form, at that time we are going to use gamma of n plus 1 divided by s raised to n plus 1. So these are the 8 important formulas which we are going to be remember for throughout this complete Laplace transformation. So these are the main formulas for our Laplace transform. So with the help of this we are going to, so here you will not get any direct question. So we need to apply trigonometric as well as the differentiation or integration results. First we need to simplify using those things, then we can go for what here, Laplace transform. So few practice examples I will just take, so that you will understand how this formula of Laplace transform will work out. We'll see the few just practice examples for understand the formula. So each we have all 8 formulas. So based on these 8 formulas, one example I will take and I will show you. So examples we'll see. So first example I will take any Laplace of any number I will take. So this number is a constant. So Laplace of this number is a constant. So Laplace of constant. So already we have seen. So Laplace of constant is nothing but, as per the previous list, so Laplace of constant is constant divided by s. So here it is 4 is a constant. So I can say that Laplace of 4 is 4 upon s. Oh, it is clear. So second example I want to take here only. So Laplace of e raised to minus t. So this is belongs to the second formula or third formula. So we know that Laplace of e raised to at is 1 upon s minus a. So here a is a constant. Similarly, Laplace of e raised to minus at is nothing but what here again minus a is a constant. So because of this minus we got plus, because of this plus we got minus. So here if you compare the same, so here e raised to minus, so value of a is minus 1, so therefore it will become a value is 1 minus 1, so it will be a is 1 here, so 1 upon s, because of this minus sign will get plus 1. Fine. So next one more example I will take. So Laplace of e raised to 2t I will take. So it will become what here? 2 divided by s minus 2. So this 2 belongs to the value of a, and here it is positive, that's why it is negative. Here it is negative, that's why it is positive. Next formula. Next example I will take by using next formula. So Laplace of 2 times cos hyperbolic of 2t. Just see. So this 2 I am going to apply linear property. 2 is a constant, keep outside. So 2 times Laplace of, by using linear property, 2 is outside. So Laplace of cos hyperbolic of 2t. Fine. Now, so what is cos hyperbolic of 2t as per the formula? So what is the formula here? So formula is Laplace transform of cos hyperbolic of at is s divided by s square minus a square, means this s and s square will remain same, only we need to update the value of a. Here value of a according to our question is what here? 2. So it will become this 2 as it is. So it will become s divided by s square, because of hyperbolic minus sign will come, and 2 square. So which is nothing but, on simplification it will become this 2 into s I will multiply. So 2s divided by s square minus 2 2s are 4. Next example will work out based on the next formula, that is Laplace of cos of t I will take. So coefficient of t is 1. So therefore answer is s divided by s square, because it is trigonometric, plus sign will come 1 square. So I can say that it is s divided by s square plus 1. Next example will work out. Laplace of sine hyperbolic of 2t or 3t I will take. So Laplace transforms sine hyperbolic of 3t. So formula is, so it is a divided by, so just I will show you the formula once again. So Laplace transform of sine hyperbolic of at, it is nothing but a divided by s square minus a square. So a value we need to collect first. So it is a value is 3. So it will become what here? 3 divided by s square, because of hyperbolic minus sign, so 3 square. So therefore it will become 3 divided by s square minus 9. So next example, Laplace of sine of 6t. So it will become 6 divided by s square, because of trigonometric function, plus sign will come, plus 6 square, which is nothing but 6 divided by s square plus 36. Now problem number 8. So Laplace of t raised to 5, so which is very important example. So I will just recall the formula. So we have two formulas here. Laplace of t raised to n. So if n is integer, that is 1, 2, 3, 4 numbers, so without fraction, at that time n factorial divided by s raised to n plus 1. If it is p by q form, it is gamma of n plus 1. So we'll see that example. So here 5 is a whole number, so I can say that 5 factorial divided by s raised to 5 plus 1. So therefore 5 factorial, it will be 120 on simplification. divided by s raised to 5 plus 1 is x raised to 6. So next I will take as Laplace of t raised to 1 by 2. So this is a fraction. So at that time gamma of n plus 1, n value is 1 by 2, it is 1 by 2 plus 1 divided by s raised to 1 by 2 plus 1. To simplify, so it will become gamma. So we know that, so few results of gamma. So few results of gamma is nothing but, so just is what here, it will be gamma of 1 plus 1 by 2 plus 1 can be written as 1 by 2 of gamma of half divided by s raised to, it will become 3 by 2. So it is 1 by 2, you keep as it is. So as per your second sum result, gamma of half is nothing but root pi and s raised to 3 by 2. So in this way, problems based on the formula I have shown you. So just glance completely, and based on this we'll see how the actual examples is going to be work out here. So thank you.